Lesson 4 notes, writing quadratic equations. When we're writing quadratic equations or converting between standard form and vertex form, we're going to have to use the method for completing the square, which we learned last unit. If you want to look back at your note sheet, this was taught in Unit 3, and it was Lesson 4. But right now we're going to go through these two examples. When you are completing the square, you're going to start with a quadratic equation. Quadratic equations are in the form of ax squared plus bx plus c, and they're typically equal to 0. When you're completing the square, you want to move your constant term to the other side. So subtract c from both sides, giving you the form of ax squared plus bx is equal to negative c, or is equal to the constant term, whatever that might be. For number 1, x squared minus 10x plus 24. We are going to subtract 24 from both sides. And we have x squared minus 10x is equal to negative 24. At this point, you take the middle term, or your bx term, you divide that term by 2. Negative 10 divided by 2 is negative 5. Then you square this value. Negative 5 squared is 25. Remember that this number is a significant number. We're going to use that later in our equation. But for now, we take our function. We rewrite this as x squared minus 10x plus 25 is equal to negative 24 plus 25. So you're adding 25 to both sides of the equation. That keeps the equation balanced. Now you need to factor the left side of the equal sign. And you have to think to yourself, what two factors multiply to equal a times c, which is 25, and the same two factors that add together to equal negative 10? And this is where that significant value of negative 5 comes in. Negative 5 times negative 5 is negative 25, and negative 5 plus negative 5 is negative 10. Instead of rewriting, or instead of factoring this entire expression, I can jump ahead because I know that my factored expression is going to be x minus 5 in parentheses squared. And again, this minus 5 is that significant value we found up here. And this is equal to negative 24 plus 25, which is equal to 1. I can take the square root of both sides, giving me x minus 5 is equal to positive or negative 1. Because we have two solutions here, we have positive or negative 1, we need to solve for each of them separately. So for the positive solution, x minus 5 is equal to positive 1. Add 5 to both sides, x equals 6. For the negative solution, x minus 5 is equal to negative 1. Add 5 to both sides, x is equal to 4. So here are your two solutions by completing the square. Number 2. Number 2 is already in the correct format with the constant term by itself, so that's good. We do not need to move the constant term to the other side. What we do have to do in number 2 is recognize that we have an a value, and we do not want an a value when you are completing the square. When you have an a value, previously we have divided it out, and when you divide it out, you're dividing it out of every term. 2x squared divided by x squared becomes just x squared. 4x divided by 2 simplifies to 2x. And 24 divided by 2 is 12. At this point, I can take my b value. I can divide that by 2. This gives me a value of 1, which is a significant number. I square this term, and that's equal to 1. I'm going to add 1 to both sides of my equation. I have x squared plus 2x plus 1 is equal to 12 plus 1. Now we can factor the left side, and you're going to use that significant number we found, so it's positive 1, meaning this is going to factor to x plus 1 in parentheses squared. And this is equal to 13. Take the square root of both sides. X plus 1 is equal to positive or negative square root of 13. Now you do have to check, can the square root of 13 be simplified? And the answer is no. So all we can do here is subtract 1 from both sides, and our solution is x equals negative 1 plus or minus the square root of 13. Okay, so that's our review of completing the square. We are going to use this process, only a portion of this process, but again, we're going to use this process in order to convert between standard form and vertex form. That's the first example set that we're going to go over. Now that we've added and subtracted 9 to the equation, which is essentially a value of 0, we can factor what's inside of the parentheses. When you're completing the square, you do not have to go through the whole factoring process. There is a shortcut, just as long as you remember that you have a significant value. In this case, it's 3. And that value of 3 is always going to be the term you use when factoring. So this expression of x squared plus 6x plus 9, this expression factors to x plus 3 in parentheses squared. 3 times 3 is equal to 9, and 3 plus 3 is equal to 6. And then on the outside of the parentheses, add your integers together. Negative 5 minus 9 is equal to negative 14. So once you get to this step right here, this is your vertex form. So we're going to write this as y equals x plus 3 in parentheses squared minus 14. So in this example, we started in standard form and we went to vertex form. Number 2, y is equal to negative 2 times x squared plus 8 times x minus 3. The first step is to group the first two terms. We have negative 2x squared plus 8x and then minus 3. So here's where the directions alter a little bit. Previously, we could not have a value, or we could not have a leading coefficient of anything other than 1, which is still the case, but we're only concerned with it inside the parentheses. So we only want to take a GCF out of the expression negative 2x squared plus 8x. Therefore, I'm going to factor out a value of negative 2. Left over inside of the parentheses is going to be 8x squared minus 4x, x squared minus 4x, and then minus 3 still remains outside of the parentheses. So again, I only took a GCF out of the parentheses and I put it right outside of those parentheses. If I was to multiply this term back in, I would end up at the original expression. So at this point, I did not change anything. All I did was factor out a value of negative 2. Now you're going to take your b value and you're going to divide that term by 2. Negative 4 divided by 2 is negative 2. Negative 2 is your significant value. We're going to square this. Negative 2 squared is 4. Now we have negative 2 multiplied by x squared minus 4x, and we're going to add 4 inside of the parentheses. Outside of the parentheses, we have minus 3, of which we are also going to subtract 4. But here's the other difference. Because you have a value that is multiplied or would be multiplied to every term inside of the parentheses, technically 2 times 4 is negative 8. Technically, you just multiplied or you just added in a value of negative 8. Therefore, this also needs to be negative 8, or the opposite, sorry, it needs to be positive 8. So when you have a leading coefficient, such as negative 2, like this equation, you have to multiply it back into your factor at the end. And again, I'm just going to explain this one more time. If you distribute negative 2 to all terms inside of the parentheses, 2 times 4 is negative 8. If we have a value of negative 8, we would need to cancel that. We would need to eliminate it. So over here, we have negative 4 times negative 2, which comes out to positive 8, which we would be able to eliminate at that point. That's the explanation for needing to multiply in, that value of 2. At this point, you can factor what's inside of the parentheses. You're going to use your significant value for that. So our vertex form has a leading coefficient of negative 2, x squared minus 4x plus 4. This factors to x minus 2, that's our significant value, squared, and negative 3 minus 4. Actually, I just realized I actually erased that. Should be minus 4 times negative 2. This would be negative 3 plus 8, and that would be 5, positive 5. So we went from standard form to vertex form. And the biggest deal here is multiplying that value of negative 2 on the end. You cannot forget that. The next example set is writing an equation in standard form. So when we start in vertex form and we are converting to standard form. These directions are much simpler. The only direction I can give you on this is to follow order of operations. So order of operations is parentheses, exponents, multiplication and division at the same time, depending on which one comes first, and then addition and subtraction, again, depending on which one comes first. So you need to follow the order of operations and multiply these expressions out. For number 1, we have negative 3. Right here, x minus 5 in parentheses squared is the same thing as x minus 5 times x minus 5. You absolutely cannot distribute that exponent. And then minus 2. I'm going to start by multiplying these terms together. When I do that, I have to use the distributive property. I have negative 3. In parentheses, x times x is x squared. X times negative 5 is negative 5x. Negative 5 times x is negative 5x. And negative 5 times negative 5 is positive 25. All of that is inside of parentheses. Minus 2 is outside of the parentheses. I do have a like term inside of the parentheses, so I'm going to simplify this. I have negative 3 times x squared minus 10x plus 25, close parentheses, minus 2. Now I can distribute that leading coefficient to all terms inside of the parentheses, leaving me with negative 3x squared plus 30x minus 75, and then we have minus 2. We can simplify our like terms for our final answer in standard form of negative 3x squared plus 30x minus 77. and this is standard form. So for this example set, we started in standard, we started in vertex, we ended in standard form. For number 2, we're going to do the same thing. Y is equal to 2 times x plus 4 in parentheses squared. This is 2 times x plus 4 times x plus 4 minus 1. We're going to distribute and eliminate our parentheses. 2 times x squared plus 4x plus 4x plus 16, close parentheses, minus 1. 2 multiplied by x squared plus 8x plus 16 minus 1. Distribute your leading coefficient. 2x squared plus 16x plus 32 minus 1. And your final answer in standard form is 2x squared plus 16x plus 31. From vertex form to standard form, this here being your standard form equation. And the last set of examples for writing equations is writing an equation given a graph. There's no specific reason or no specific way you need to write these equations, so my suggestion would be to use vertex form because it's going to be a lot faster. All right, so my directions say to choose a point and the vertex, and you're going to solve for A. So recall that the vertex is h comma k. If that's the case, and I pick my vertex, there's only one vertex. And in this example, that vertex is at 3 comma 0. I know that the 3 value is my h and the 0 value is my k. I'm also going to pick one more point. You can pick any point you want. So it appears that there's 4 nice, easy points for me to pick from. I'm going to pick this point right here. So let's pick 2 comma 1. And I'm going to label this x comma y. So now I'm going to take these two values, my vertex and my point, and I'm going to substitute them into the vertex form. Vertex form is a times x minus h in parentheses squared plus k. When I do that, my h value is 3, k value is 0, that's from my vertex. My x value is 2, y value is 1 from the extra point. So we're going to substitute 1 in for y. 1 is equal to our a value, and then our x value is 2 minus the h value of 3 plus our k value of 0. I need to simplify and I need to solve for a. In order to solve for a, I'm going to have 1 is equal to a multiplied by 2 times 3, which is negative 1 in parentheses squared, and we don't need to write plus 0. 1 is equal to a times 1, or 1 is equal to a. For your final answer, you only want your a value, your h value, and your k value. Recall that anytime you have something in vertex form, you still have an x and y variable included in your function. So you need that when you're writing in vertex form. So I'm taking only the two parts I just highlighted in green, and I'm going to write my final answer as y equals the a value of 1 multiplied by x minus 3 for my h value in parentheses squared plus 0. Now I can clean this up and write it as y equals x minus 3 in parentheses squared, and that's it. This here is my final answer in vertex form. So rewrite the final answer, oops, I forgot the R, using the h value, the k value, and the a value. H and k are from your vertex, and the a value is what you solve for. Number 2. For number 2, our vertex is at negative 4, 0. Negative 4 is your h value, 0 is your k value. I'm going to pick this point right here. The extra point I picked is at negative 3, negative 1, which is your x and your y value. We're going to substitute these values into the equation. Y is equal to a times x minus h in parentheses squared plus k. I currently have a value for y, for x, for h, for k. Substitute in the y value of negative 1 is equal to a, x value of negative 3, minus your h value of negative 4 in parentheses squared plus the k value of 0. Negative 1 is equal to a multiplied by negative 3 plus 4, because a double negative is a positive. Negative 3 plus 4 is positive 1 squared plus 0, or negative 1 is equal to a. Negative 1 is your a value. Your h and k value are pulled right from the vertex. And for my final answer, I'm going to write this as y equals negative 1 multiplied by x minus negative 4 in parentheses squared plus 0. Clean this up for my final answer of y equals negative x plus 4 in parentheses squared, and I don't need to write plus 0.